It's a bit
Stuck.
dark. What about this information?
Don't worry, I think it's good. You're live on YouTube.
YouTube? No, the YouTube.
Sister, you're live on YouTube.
Right now.
Yes.
Uh,
So
Everybody's watching us.
everybody's watching you.
Ah.
Don't for use your sticks. It's, it's dark.
And maybe we have to move this one away.
And where? You're talking of YouTube, you're talking of TikTok. Fight Charles, respect yourself.
So now move it.
I can go, let me just sit.
Just set that. So shall we?
You have moved to this other side that there's fan.
So shall we? Okay. So the different time that refers to the graph or the plots of displacement x on the vertical axis and the time on the horizontal axis. The displacement x is measured in meter and the time on the horizontal axis is measured in what? Seconds. So that will now be velocity. The slope with velocity. If it starts from the origin, it's called positive graph. If it does not start from the origin, if it cuts x and y axis, it's called negative graph. So if I have displacement x, it's going to be um, sorry, velocity is going to be change in displacement over change in time, dx dt. The rate of change of what? Displacement with respect to time is velocity. Abi, would you know this? Don't forget I mentioned in the definition in the last class that the rate of change of displacement with time is velocity, and velocity is a speed measured in specified direction because it is a vector quantity. Are you get my point? So the rate of change of displacement with time is velocity, measured in meter per second, which will always count. You also can write as v equals to x2 minus x1 over what? T2 minus T1. So if you plot the graph, time in seconds, x in meter, the positive graph will move from the origin. It starts from the origin where 0, 0, where x is 0 and time is 0. So it's called a positive graph. So when it moves, you measure that it moves with a uniform velocity. Uniform means it is moving at equal displacement at equal time. Equal displacement at equal time. So um, when it is moving, they'll say you first measure some seconds. You say it moves with a particular seconds. After all, it moves with uniform velocity. Then at a particular seconds again, it decelerates. You understand? It decelerates. So they will not mention one or two things. Then at the end of the day, we know that slope of the graph represent what? The velocity. The slope of the graph represent the velocity. You know that the slope is what? Dy over what? Over the x. And the velocity also represent the same thing, which is what's the dy? You change y. Dx, which is displacement, over what? Over the t, which is the time. Is that clear? So when you're saying slope, dy dx, y2 minus y1 over what? X2 minus x1, is also representing velocity, which means what? Change in what? Displacement, which is vertical, over what? Change in time. So the slope of a graph of displacement versus temperature versus time is a typical what? Velocity. The slope is a typical what? Velocity. So jot it down. Now we look at something on that. Now, if I go to the next part, let's take one question from Wire. 23 watts, what did you? Question 50. The drill diagram is like 9 per seconds. Now it's 0 here. Now it's 40. The diagram below illustrates the velocity graph. Determine the distance between x and y.
Who snap it to me? Let's see.
So are we there? Yeah, true. Okay. So that question does not require any more stress. If you check the total vertical distance there, that was 40 meters. We are not actually asking of velocity. We are not asking us for velocity. If we are asking of total velocity, There is change in velocity. You know, this is the distance. The change in velocity. Velocity is total distance. That's distance divided by what? Time. That will be what? Then you can also say another big what? Distance. Still on that uniform motion. 40 divided by 8. That's what. So our total velocity now is what? 10 plus 5, which is what? 15 meter per second. Now, after that, when we know the total velocity, we want to know the total distance between x and y. Total distance between what? X and y. So, from 4 to 8, what does it mean? When we say time moves from 4 to 8, what does it mean? Does it mean that the total time from year to year, from 0 to 4, from 4 to 8, what does it mean? Between 4 and 8, what does it mean? Is it like it's increasing or there's a difference? Like difference is 8 minus 4, or 8 is the total time. Don't be confused from what I'm saying. Like from 4 to 8, notice from 0 to 4, from initial speed. Initial velocity is 0. I mean, but started from where rest is this origin, where u is 0, or where v is 0. So velocity over time for the first distance, for the main distance 40, velocity over time. Velocity over time again. But if we are sorry, not velocity, I mean displacement. This is displacement. Don't mind it. This is typographical error. You mean because it said velocity time graph. That's supposed to be an acceleration. I mean, velocity time graph. So that's supposed to be an acceleration. Sorry. You are here to mention that. Not displacement time graph. So if I want to get them right, it means velocity in what? And time in what? They need to put all of that. So this is total acceleration. I get my point. So what's the total time between 0 to 8 for x and y? The first at distance x is for what? T1, that was what? For distance y, that's T2. It's going to be what? 8. That's increased again. Now, what's the total time? Total time is what? 1 plus 8, Abi? That's 12 seconds. So at the end of the day, what's our distance? Our distance will now be what? We may not even need total distance. We may not need total acceleration and total time. If you say A divided by 4, it will still make sense. So the best way is we'll go for some B, 40 meters. There are some questions they don't need any solving at all. I get my point. They don't need any solving. All they need is simple manipulation. If there's no error in that question, we'll go by 40. Okay. Okay. Now I get the right way to go about it now. This is not the perfect way. You know that this is not distance. This is velocity. So we may not look into acceleration. Let's use a simple logic without going through all of it. So the best way to go about it is when we are given velocity is 40 meters per second. For a given time t1 to what? 4 seconds. Time t2 to what? 8 seconds, right? Now, you know that our velocity, our distance is velocity times time. I mean, because velocity is what? Distance over time. What will be our distance? Velocity times time. So our first distance was what? For x at what? At x journey. So you get speed is what? 40 meters per second. Times what's our time? 4. That's what? 160 meters. I mean, for S2 at point Y is going to be this speed 40 times the second time 8. That's what? 320. So what will that be our distance between X and Y? It will not be the difference between point X and what? Point Y. So we now have distance between what? X and what? Y. Now be highest distance minus final distance minus initial distance. So now give what? So I'll go by this. I'll go by this. Treasure. Somebody's calling me. My response is one of the students. I have to let them know that we are engaged, that they will not be disturbed.
Okay.
So we will be able to understand this one. Anytime we are talking of distance from velocity time graph, we multiply velocity by time. But anytime we are talking of acceleration from velocity time graph, we divide, because velocity divided by time is acceleration. If they say what is the total acceleration, you tell you like it's 10 plus 5, 15, that first approach. You understand what I'm saying? But when they say distance, you want to bring distance out of velocity time graph. What is distance? Or what is displacement? Velocity times time. You can see velocity times change with time. Velocity times what? Change with time. We can do it as velocity distance between x and y can be v delta t times that's what's v 40 times 8 minus 4 like this. 40 times what? 8 minus 4. This is the highest time minus the lowest time. And that will not give you what? 40 times 4. That will not give you what? 160 meters. It's still the same thing without passing through this slow process. Is that understood? Any question? Any further question? We are going to the next question. The next one here says that let me allow you to get so I go to the next one. Now, before I go to any calculation, any past question, let's complete this. This is displacement over time, which is displacement time graph, which gives velocity. The second one now, because I'm seeing enough questions to solve. Before we solve up to 6 questions, we have to treat the second part, which is the real velocity time graph. So for this displacement time graph, I've not given any questions so far. I'll give you question for everything. Let me just complete. What's the meaning of velocity time graph? The displacement time graph is what? Velocity is slope when the rate of change of displacement with time is obtainable. Now, have you written this? Can I clean this? How to clean this? Number 2, velocity time graph. This is the rate of change of velocity with time. If you are obtaining acceleration, it starts from the origin. But if you are decelerating, this is acceleration. Acceleration is the slope. Acceleration is what? The slope of the velocity time graph, which is dv dt. As acceleration is dv dt, the slope is representing dy over what? The example y is representing velocity, change in velocity, v2 minus v1 over what? T2 minus t1. So do not forget that acceleration can also be obtained by the coordinate of 2 points. Acceleration will be given as the 2 points will be t1, v1, t2, v2. So acceleration will be v2 minus v1 all over what? T2 minus t1. In your coordinate geometry, that's why math. Without math, forget physics. Whether you're doing biology, in JAM, YL, or not, you need math as a physics student. That's one of physical science. So this one is x1, y1. This one is what? X2, y2. So now, if acceleration is this, between these 2 points, what's our slope? Y2 minus y1, I mean, over what? Which is still the same thing as y dx. Is that clear to you? Now, come and say a question like this. Why 16 question? Yeah, I think I've given you one. Let me give you another graph for deceleration. If I go to that past question. Velocity versus time. This is how the graph will be. This is how the graph will be. On the velocity time graph, you will hear from uniform motion. From uniform motion and brought to rest. From what? That is this graph. This is you start like this. Uniform motion means horizontal, then brought to rest to decelerate. These are the graph will be. Many of these questions will come out. You see them now. So, in case in a velocity graph, here, what is the total distance covered? What is the total distance covered? It will be an area of trapezium. Total distance covered is representing area of trapezium. In a velocity graph, they will ask you. You say a body starts from rest and accelerates uniformly, and after some few seconds of journey, it now decelerates. So you mention different stages. This one will be like T1, the second stage. This one will be like T2. You now say decelerate to T3. When it ends the journey. So the acceleration will now be obtained. To find acceleration, they can find the distance, but to find total distance, total distance represents area of trapezium. Is this not the shape of trapezium? Area of what? Trapezium. Now, what's the area of trapezium? You know, total distance says total distance is also representing average distance and time. You know the formula for total distance is what? Average velocity multiplied by what? Time, Abi. The same way this statement exists, is the same way total distance represents area of what's the area of trapezium? Some of the two parallel sides. What are the two parallel sides there? This one and this one. The sum of the two parallel sides. That's your velocity. Velocity at this time, velocity at this time. So it's like half open brackets, half into sum of the two parallel sides. Let's say this one is A and this one is B. A plus B times what's the height? The velocity. But we are not going to use velocity, we can use height. We can use height. So when we now get the question, theory question, you can come up with it. So you should look for the total distance traveled. Some of the velocity at A and at B. So there are two questions that will come out, there are two questions I'll be solving from here in this pattern. Two. That's 1 year on that. Can I clean inside? Can I clean inside? I'm going down. Don't forget that A and B represent the time. Do you understand? That area of trapezium that is here, both of them represent time. That's T1 plus T2. Then height now represents velocity. Is it clear? That means I wrote total distance, area of trap. I see it.
Yes.
Now I wrote the formula for area of trapezium. This is equals to half into A plus B times H. On the velocity time graph, to represent it as, I represent it as a normal formula of measuration. Where they say I have to sum of the two parallel sides A plus B. This is it. This place from here to here is A. Right from here to here is A. The second parallel side B. This is A. This is B. But our usual trapezium are B. But because it is representing time, you can also write this one as half it what? T1 plus what? T2 times B. Height is in B. This is the height. Do you understand? Do you understand what I'm saying? That question that we got 160 meters. Who can tell us the area under that graph? Who can get it? Eh? No, that's not the one. I'm asking that thing. I'm coming to this. What's the area under the graph? What's the total distance covered? That question that we got 160 meters. But yeah, what's it? We can try. They gave time 4 seconds, 8 seconds, and they 14. Total distance travel. Total distance travel in that velocity time graph. Eh? 120. Are you sure? What? 480. Why? Using this formula, just give me my mind. Have you given this question? Don't be fast to forget something. This one from here to here, 4 seconds. God did it now, not even up to 1 hour. 40. What is the total distance here? 200 and what? 40 meter, correct. I'm not sure. Are you sure? 100%?
Yes.
Yes, 100%. That's perfect. Just say 4 plus 8, 12. 12 times half, 6. 6 multiplied by 40, 240. Half into sum of the two parallel sides. What are they? Sum of the two parallel sides. 4 plus 8. That's 12. 12 times half, that's 6. 6 times height, which is 40. 240 meter. Are you getting what I'm saying? You can see that that question does not ask you, that first question we did, that we got 160 meters. It does not ask us to look for total distance travel. They say find the distance between X and Y. Distance at X from zero origin was 160 meters. Distance at Y from zero origin was what? 320 meters. The change in distance between X and Y, the point X and Y, will be 320 minus 160, which is equals to what? 160. If you are not careful. So I know some people go and solve this. Thank God the option was even helpful. There was only like 240 meters. And did they put for 240? They put 20 meter, 40 meter, 160 meter. They put 80 meter or something like that. If you were to put 240, some students would have chosen that 240. Not be today, that students have been foolish. If you say total distance travel, you should know that it is what? Area under the velocity time graph, which is what? Area of trapezium. I just look at it still on the board now. See what the parent now. So now, if I say distance between one point to the other, you get the distance at one point, you get the distance at another point. Now subtract them. Don't worry, you have a number of questions to solve. Pay attention. You are going forward. Go to the other and everything. Oh yeah, we can solve this. Yeah, that girl. How far now? This one.
3, yes.
Yeah, that's what?
3.
Eh?
3.
3 meters per second.
Yes.
Look at the short one. 60 minus 15. 45, Abby. 20 minus 5. Eh?
15.
20 minus 5.
15. 20 minus 5 now. 15.
Wait, hold on. 60 minus 15.
45.
45 divided by 20 minus 5.
15.
45 divided by 53.
3.
3 meter per second square. That's the shortcut. From B. That's correct. Thanks for that. You guys are doing well. Oh, yeah, do the second one. Shortcut. Divided by. Oh, yeah. Let's go. Don't wait. Which calculator? Oh, calculator. It's 2 meter per second square. Abi?
Yes.
50 minus 10. 40. Or just that you're looking for slope. X1, Y1, X2, Y2. That's a Y2 minus Y1 over what? X2. That's I said that slope in a velocity graph. You understand? For an acceleration. Acceleration is slope, which is on a velocity graph. But displacement on a displacement graph, the slope is velocity. Do you understand? Just like x1, y1, x2, y2 that we're talking about is y2 minus y1 by x2 minus x2. It means x2 distance, x displacement x2 minus x1 over time t2 minus t1. That will now be what? Your velocity. So velocity on the displacement graph has a slope of what? The slope on a velocity graph, sorry, the slope on a displacement graph is velocity. Why the slope of what? On velocity graph is acceleration. I said it before. So 50 minus 10, 30 minus 10, 20, the answer is 2. Can you see how simple it is? Now, still going through partial sums. Write everything on the board. Okay, let's look at another past question. Which one should I clear first? That's that. We have a lot of questions here. That's why I like the 50. We always have enough questions from different years compared, let's say like 10 to 15 years. They never did solution boards and commend their efforts for selectively and eloquently giving that time as a point of view to select everything. Because even that is true. Now let's first talk OBG, not the theory. Those theories are they have branches of questions to be solved under each velocity angular question. And many students will do those questions in theory. We are looking at it. So I'll solve 2 years. You now solve for 17 years of your own. And you find it easy. No matter how difficult it is, I'll break it down to simplicity and you guys will solve your own. Now let's first go to OBG. The first question I want to talk about is he said 1988 question 2. Because there will not be time for me to be dictating everything. But when I get to theory, I'll start dictating. Now this was OBG. Number 1. The first question is was 1988 question 2. It's an OBG. Just listen the way I'll just dictate the question. I'm not going to dictate, I'll just read the question out. Then you listen, then you now pick answer, because that one is not calculation. It's just a question that requires you to have an ideology applied completely on what? On the question. So just like what I've said about slope, whatever, as you're hearing it, the answer should come to your mind. If I read the question, allow me to learn on the options, then you now listen carefully and pick the option. Now look at it. There's no one starting ahead. One started in 2000. Like what is your one? It's on Facebook. And Facebook started 2008. Again. Poverty starts with sin x all over x. X cancel x, that's why it's sin. And that great poverty is why I say sin x over n. N cancel n, that's why it's 6. What kind of math is that? Is that supposed to be a government? Stupidity. Why yeah? Okay. So let's go there. Right. This person says the slope of a straight line, displacement time graph indicates straight line what? Displacement time graph. The slope of a straight line what? Displacement time graph indicate that. Just listen to my option. After option, tell me the answer. A, distance traveled. B, uniform velocity. C, uniform acceleration. D, acceleration at an instant. What's it? The slope of displacement time graph. We are not paying attention. I can't repeat any question again. Because I want you guys to get used to how to be very smart with your answer. If you are delaying yourself, repeat the question, you don't get the answer. Just put your mind and get it right. It's very simple. The slope of a straight line, displacement time graph. I've written the symbol for you. This is displacement time graph. If it's distance time graph, it's still the same thing. It's just that this one is what? Scalar. And this one is what? Vector. That's the difference. Now they say the slope indicates what? A, distance travel. B, uniform velocity. C, uniform acceleration. D, acceleration at distance. B, uniform velocity. It's faster than everybody. That's why it's uniform velocity. Keep playing. Don't pay attention. Uniform what? Velocity. You just started today. So I've gotten now. You are here. You watch it. You're looking like Lookman or Lucozid. Look at this. I just see now that the slope of a displacement time graph represents velocity, which is the x distance, rate of change of displacement over time. The x dt is velocity. I mean, which means of a displacement time graph. Simple question. Now, let's take the next step. The trade diagram like this. And the rest is here. This is 5 seconds. This is 20 seconds. And this is 25 seconds. This space was not given at all. It was D meter per second. Let's say that from this diagram, which is speed. Hello guys, if they say speed time graph, what does it mean? It's still velocity time graph. The same approach. Just in your mind that you know that speed means normal distance over time. While velocity means displacement over what? Time. I mean, the velocity time graph is a vector quantity. While speed time graph is what? Scalar quantity. Now I said, if you can't cover the total distance of what? It covers the total distance of 600 meters in 25 seconds. In what? 25 seconds. The question is number page 10, question 2. Have you seen it? So, what are we going to do? They said, calculate its maximum speed. V max. Calculate the V max. Who can solve it? Anytime we have total distance, it represents area of that trapezium. And we are looking for maximum speed, which is total distance, total time. You are not getting something there. You are not. It's making sense when you reason that area under this trapezium is what? Total distance, which is equal to half into like what? Sum of the two parallel sides times height, which is velocity. We are looking for the maximum, so this is the max. This is the V max we are looking for. The total time. What's the total time? The initial at 5 seconds. That will be 20 minus what? No, 20 minus what? 15. Then at 25 seconds. 25 minus what? After I now get a T1 and T2. I get my point. Then your distance of what? But never mind. They said it's even simpler from total distance. What's that total time? What's that total time? So you don't even need to break it to don't worry about that. So yeah. 60 meter per second. No, actually 30. Let me give you the option to guide it. 30 meter per second. B. 25 meter per second. C. 20 meter per second. 20, 15. Priscilla. When the multiply is 60 by half. Is that not so? What's your name? Valerie. Okay. Don't worry. I'm watching my best student in my class now. What's your name? Eh? Yes. Okay. 30. How did you do about it? This is what you do. Okay, you use shortcut mathematics. That one I did. Okay, you do the calculation. Oh yeah, let me confirm. Um, Valerie, what's that?
What I saw, what I
Why? What happened? You have everything on the board. In fact, the formula I just gave you now should have been the best of who want to help to get the answer. Priscilla, how far now? 60. Hey! Hey! What is going on? You are still confused with my explanation. I said don't use 15 plus 5. I just told that 25 seconds is there now. I just told you now that I've forgotten the date 25. I was not there to use our usual with our old school way that we used to use before. But now, I'll tell you where you are going to do subtraction. That's why you have to understand this part, in theory part, especially. This will be good. So they gave total distance travel with the total time of what? 0 to 25 seconds. So now, we are looking for maximum velocity. And oh yeah. Class, you are not asking me a question. You are not asking me very critical and sensitive question here. Why are we using area under the trapezoid? Nobody is asking me that question. Because the measure what? What's the formula for total distance? Normal. What's the formula for total distance? Normal. B plus U all over 2 times T, which is now converted to what? It's still the same formula. It's just the symbol, it's just the parameters that are different, which is now converted to total time divided by 2, multiplied by what? This one is the real formula in uniform motion. Other meeting first, second, third equation of motion. But this one is the what? Is the formula of the measuration. This formula of measuration is what? Sum of the two parallel sides. What's the first side? This one and addition of this one. From year to year. From year to year. Plus from year. That's what became 25. I get my point. So what's the total distance now? Using this formula. You are sick of that. You are your own. Oh yeah, what we now? You are here to learn. Half into bracket. C1 plus C2 is what? Has been given like that already. So no need. From 0 to 25, total journey gave the total distance of 600 meters, and the total time was what? Between 0 to 25, with 25 minutes. You've given it to the question. And that was what?
Yes.
Times.
The question is not correct.
The question is not correct. What happened?
Options are not correct.
What did you get?
48.
48, Abby?
Yes.
Okay. I get what is going to happen here now. Let's use my initial ideology. The ideology is from year to year is what? From year to year is 5. From 0 to 20, you have to remove this 5 from 20. That's your T1. 15 seconds, I mean. Your T2 is the time. The time has to be deceleration moment. The time has to be small. And that's what. You are going to get the answer now, not this one. So now I have 600 is equals to R into 5, 15 plus 5
That's 20.
times B.
That's 10.
20 times this. The question must be wrong there. Yeah, the question must be wrong. There must be something wrong with the question. But that's the correct answer. Yes.
So 7 or 7 B. Without further ado. Because 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 there's no sign of being like it's fine. Objective is like it's 15 plus 5, that's 20. Divided by 10. How is it divided by 60? 10. That's wait. What do you guys do? Sure. 600. Yeah, of course. I'm not 15. I'm 15. How did you go?
Yes.
Yes. Sunday or not? Sunday or there is a guy. Whenever you bought this thing from it, ask myself, no, if I like saying, oh, I wait it, let's because I will not die. $50. I'll always remember that that thing is like, oh, you know, this one is so different. But she used to buy it. I think she gave you the first thing I don't know. Second one, I guess. Next one, I 15. 15 is inside the bottle. So, like, there's another that's it. Why you talking about come on, Mimi. Because of the really this is not talking about. Wait, what's the cost of one? No, that's sauce. What sauce? I think people they go to my corner. How does she Joshua do? Even Joshua was one of them. From Joshua. There's even Joshua do that every episode to actually get something instead of food. I was like, if I'm going like this, she just go and open my chest. I started to just manage it. Yeah, that man can be wrong. That's my fear. Not supposed to be food. You cannot be food. But I've noticed, I've not eaten this thing like 1 year. I've been eating it. Because today, as far as your food, I don't put it. I don't understand. I don't put any of it. Because he didn't know what to talk about. He was like, I go there, this stuff. I was feeling like this because I knew you were feeling like this. I was like, I thought this exactly what I should that was exactly that. No. She forgot herself. Come for this, yes. Another way, another like another topic that so she's got like that. When you just that's a fact. Look at my remember that. It's a religious person. Another way that Islam is based
Ela marafa.
You get it?